Hello students of class 10, and I hope you all are doing well. So here we will be starting a new topic based on the last discussion in the class, that is metals and non-metals. And in the last class I explained to you all about the physical properties of metals and non-metals, and today we will be discussing about the chemical properties of metals. Now when we are talking about the chemical properties of metals, in fact it is the reactivity. That means under favorable condition a single compound may undergo decomposition, or it might also combine with other substances to form a new substance or a compound which has a different chemical property from the substance which is being formed, and from the substance which is being formed from the substance with which it has reacted. So that we will be having a proper discussion about it. And then the first chemical properties that we will be discussing is what happens when metal reacts with air. What happens when metal reacts with air? Now it was the first reaction that you all have learned in the chemistry part when we were talking about a magnesium ribbon which has to be cleaned with a sandpaper, and then we bring it near a burning candle or a Bunsen burner and allow it to burn. Then we will get a white color ash, which will actually it is magnesium oxide. So when we that was the first reaction, that is magnesium. When it reacts with oxygen, then it forms magnesium oxide. Now when it forms magnesium oxide, of course this is not balanced, so you need to balance here 2 and 2, magnesium 2 atoms and 2 atoms, and oxygen also 2 atoms. That means this will form a white color ash, and then magnesium oxide will be formed. Now when you are talking about other elements, like suppose copper. So what happens in copper? Like suppose copper, it reacts with oxygen, then you will get copper 2 oxide, because you know that copper has a variable valency, and this here the valency of copper is 2, and this will be a black color residue. But that means the copper, you have learned that how will you determine whether a chemical reaction has occurred or not. That means there will be sage in color. Here there will be sage in color. That means copper oxide will be formed. Now that copper oxide is black, will leave a black residue, and that means, as you know that copper is a metal, that is why it will form a metallic oxides. And remember, I told you in the previous class also that metal oxides are actually acidic in nature, are basic in nature, and they turn red litmus to blue. So when we are talking about, that means when metal reacts with oxygen, then metal oxides are being formed, reacts with oxygen, then metal oxide is being formed. And these metal oxides are generally basic in nature, and they will turn red litmus to blue. Similarly, if you talk about aluminium, then what will happen? You will get aluminium oxide. So when it will react with oxygen, then you will get Al2O3, right? So here, of course, this reaction is not being balanced. So if you put here, right, so this balances the reaction. That means here number of aluminium is 4, right? This is 4, and here it is oxygen is 6. Now here you see 2 into 2 is aluminium, it is 4, and 2 into 3 for oxygen it is 6. So that means aluminium oxide is being formed, and this is a balanced reaction. And generally, as I told you, that the metal oxides are mostly basic in nature, but there are some metallic oxides which actually reacts with both the acids and the base to form a metal oxides which is showing the characteristics of both basic and acidic in nature. So those elements, those metals which react with both acids and with base, it is known as amphoteric oxides. So when this is known as amphoteric oxide. Now for the and the example for amphoteric oxides are aluminum, zinc. Now you have read in the previous lesson, that is acid, bases and salt, that when zinc reacts with sodium hydroxide, then it forms sodium zincate. Similarly, when aluminum oxide will react with hydrochloric acid, then what will you get? You will get the salt along with the water. That means it will give you AlCl3 plus H2O. Right? So what happens when this reaction is also not balanced? So when you have to balance it, then what will happen? You will get here 6, so 2, and then here 3. So here you see aluminum oxides, when it reacts with hydrochloric acid, it will form aluminum chloride, which is a salt, along with the formation of water. So this balances. Look here, there are 2 atoms of aluminum in the reactant side, and here also you are having 2 atoms of aluminum. Now oxygen is 3, right? So here oxygen is 3. So when you are for hydrogen, it is 6. So here 2 into 3 is 6. Then chlorine is 2 into 3 is 6. So that balances the reaction, and that means when aluminum oxide reacts with hydrochloric acid, then a salt is being formed along with the formation of water. So the similar way, when aluminum oxide will react with sodium hydroxide, then sodium aluminate will be formed. That means NaOH. So it reacts to form sodium aluminate plus water. Similar is the reaction. It is quite similar to the reaction of zinc oxide when it reacts with sodium hydroxide, which is an alkali, and then it will form sodium zincate. Here this one is sodium aluminate along with the formation of water. So these metallic oxides are generally insoluble in water, but there are some of them they are soluble in water and they form alkalis, right? Like especially with sodium oxide, Na2, so they will react with water and they will form sodium hydroxide, right? And along with that, so here what happens here is that you will get sodium hydroxide, which is an alkali, and it is soluble in water. Similarly, K2O, when it reacts with water, then what will you get? You will get KOH. Similarly, so this is a balanced reaction. Okay, so that means these metallic oxides they react with water to form alkalis, right? And as you know that alkalis are those substances which are soluble in water, those bases, which are soluble in water, and these all metals they do not react with oxygen and at the same rate, because you know there is a reactivity series, and that reactivity series will decide the rate of the reaction that the metal will have with the water. with water. So that is different metals, they show different reactivity according to the reactivity series, right? So and these metals like potassium and sodium, they react very vigorously with water, and then they will form in fact they will catch fire if they are being kept out in the open. So to preserve this type of very reactive elements like sodium, it is preserved under kerosene so that a barrier is being formed with the air with the oxygen of the atmosphere, and then so that sodium does not get the chance to react with oxygen, and then sodium oxide will be formed otherwise. So and it will burn when it is kept in the open. So that is why it is being covered with it is being stored under kerosene, and then this magnesium, aluminium, zinc, and lead, they are covered with a thin layer of oxide. So this protective layer, it prevents the metal for further corrosion, right? So like I think you all have learned that how corrosion is helpful. Sometimes generally we know that corrosion is it causes damages to the different parts to the metals. But when aluminium reacts with oxygen of the air, then it forms a protective layer over the metal, and it prevents further corrosion, and that is why corrosion as a whole is very essential. In fact, it prevents from further damages. So that is why this corrosion with aluminium or zinc is helpful. So this aluminium oxide creates a protective layer or a layer of oxide, right? So and why it is oxide? Because it forms a compound with oxygen. So this copper, they do not burn, but the hot metal is coated with a black layer of copper oxide, and silver and gold. Generally, you know them as a noble metal, and these noble metals, they are very unreactive. They do not react so easily with air. Only when silver is being exposed to some poisonous gas like hydrogen sulfide, then what happens is it will form a black coating of silver sulfide, and that prevents that actually can be cleaned up. You must have observed your mother cleaning up the silver ornaments with toothpaste because it is alkaline in nature. The acidic character is being removed from the metal. So here I'd like to end here talking about how metals react with oxygen of the air, and how this forms that is what is amphoteric oxides, and also metal oxides, though they are basic in nature, they might show some elements like aluminium, some metals like aluminium and oxygen may show both the characteristics of metal. So exhibit reaction with oxygen which means they might react with base and as well as with acid, and that will form amphoteric oxides. So till that time, you have a good time ahead, but please go through the lesson also very carefully. Thank you very much, and may you have a good time ahead. Thank you.